Have you ever wondered about the mysteries of the sun? How does this giant ball of fire, a million times larger than Earth, affect our lives? If you've ever looked up at the sky and pondered these questions, you're not alone. Since the dawn of civilization, the sun has been a source of fascination, inspiring awe and curiosity. It's not just a celestial body that provides warmth and light, it's a complex dynamic system with many enigmas. Consider the solar wind, a stream of charged particles that the sun continually spews into space. Or the solar flares, those sudden intense bursts of radiation that can disrupt our satellites and power grids. And then there's the corona, the sun's outer atmosphere, which is inexplicably hotter than its surface. What causes these phenomena? How do they affect us and the vast expanse of space around us? These are the questions that led to the birth of a daring mission, the Parker Solar Probe. In August 2018, NASA launched the Parker Solar Probe, a mission daring to go where no spacecraft had ever gone before. This brave little probe was tasked with a monumental challenge, to venture closer to the sun than any predecessor, to endure and thrive in the face of intense heat and radiation. The Parker Solar Probe, named after astrophysicist Eugene Parker, was not just designed to survive in these extreme conditions, but to study and understand them. Its primary mission? To unravel the mysteries of the sun's outer corona, to comprehend the solar wind, solar flares, and other solar phenomena from up close. The journey was not without its challenges. The probe had to endure temperatures over 1,000,000 degrees Fahrenheit, and speeds fast enough to get from Philadelphia to Washington, D.C. in 1 second. But it was designed to withstand these conditions, to brave the unknown. With its launch, the Parker Solar Probe ventured into uncharted territory, closer to the sun than any previous spacecraft. As the Parker Solar Probe ventured closer to the sun, it began to unlock the secrets of our star. This journey into the unknown has led to some profound discoveries, which have challenged our understanding of the sun and its behaviors. Firstly, let's talk about the Parker Solar Probe's closest approach to the sun. This intrepid spacecraft has journeyed closer to the sun than any previous mission, getting within about 4 million miles from the sun's surface. Imagine that. A man-made object, standing up to the intense heat and radiation, and surviving a close encounter with the most powerful object in our solar system. This unprecedented proximity has allowed the probe to capture high-resolution measurements and images, providing us with a unique perspective of the sun. Now, on to the second key discovery. The Parker Solar Probe has been instrumental in providing unprecedented data on the solar wind. Imagine the sun as a giant fiery cauldron, constantly spewing out a stream of charged particles known as the solar wind. This solar wind travels through space, carrying with it the sun's magnetic field, and it plays a crucial role in shaping the space weather conditions throughout our solar system. Before the Parker Solar Probe, our understanding of the solar wind was limited. But now, the probe has enabled us to study the solar wind's behavior, speed, and composition as it emanates from the sun, in real time and up close. This has offered us a deeper understanding of how the sun interacts with the space around it, and how it influences the space weather conditions that can affect Earth and other planets. These groundbreaking insights are not just interesting facts for us to marvel at, they are significant pieces of a complex puzzle that is our sun. Each discovery brings us one step closer to understanding our star and its influence on our solar system. But the Parker Solar Probe's journey was far from over. It had more secrets to uncover. The Parker Solar Probe continued its mission, delving deeper into the mysteries of the sun. One such mystery has been the sun's magnetic field, a force so powerful, it shapes the solar environment. The probe's journey uncovered precious insights into this magnetic field. It revealed how the field influences the formation of solar storms and coronal mass ejections, phenomena that can have significant effects on Earth's technology and space missions. A better understanding of this magnetic field is crucial for predicting and preparing for these solar events. But the probe's mission didn't stop there. It confronted one of the sun's most puzzling enigmas: the heating of the corona. The corona, the sun's outer atmosphere, is surprisingly hotter than its surface. This counterintuitive fact has baffled scientists for decades. The Parker Solar Probe aimed to shed light on this phenomenon by studying the processes that heat the corona. Although the full answer remains elusive, the probe's findings have brought us closer than ever to understanding this solar riddle. Finally, the probe embarked on an investigation of solar energetic particles. These are high-energy particles in the sun's atmosphere that are accelerated and released during solar events. By studying these particles, the probe has provided invaluable data. It has helped scientists understand how these particles are accelerated, how they move, and how they interact with the solar environment. This knowledge is essential for understanding solar radiation, a key factor in space weather and its effects on Earth. The Parker Solar Probe's mission has been nothing short of groundbreaking. It has ventured closer to the Sun than any other spacecraft, providing us with unprecedented data and insights. It has deepened our understanding of solar wind dynamics, the Sun's magnetic field, the heating of the corona, and solar energetic particles. These discoveries have revolutionized our understanding of the Sun and its influence on space weather. The Parker Solar Probe has not just ventured closer to the Sun than any previous spacecraft, it has also brought us closer to understanding our star. This intrepid explorer has unveiled the dynamics of the solar wind, giving us unprecedented data on its speed, behavior, and composition. It's shed light on the mysteries of the Sun's magnetic field, revealing how it shapes the solar environment and contributes to the formation of solar storms and coronal mass ejections. The probe's journey has also brought us closer to understanding the enigma of coronal heating, exploring why the Sun's outer atmosphere is hotter than its surface. And let's not forget its investigation into the energetic particles in the Sun's atmosphere, providing invaluable data on how these particles are accelerated and released during solar events. Each discovery is a step forward in our understanding of the Sun and its influence on space weather, potentially helping us predict solar activity. The Parker Solar Probe continues its mission, ever closer to the Sun, ever closer to the answers we seek about our star.